Hi, this is Kevin Trainer, and I'd like to welcome you to my tutorial on normalizing within logical database design. And if you look at the graphic that I have up, you'll see that we're working on the logical database design process, and we've come to the third subpart, the one called normalize. And so we're going to work our way through that now. So that consists of removing the redundant columns, removing redundant relationships, eliminating repeating columns, relocating misplaced columns, and replacing free-form text fields with lookup tables. So this is a lot of stuff. These are all things that fall under normalization. So what is normalization? Normalization is a process of improving the goodness of a relational database design. Okay, so database designs that are more normalized are said to be better. Okay. For the kind of applications that we're learning about right now, which are data structures to support online transaction processing. So traditionally, this is the main use case for relational databases, and it's certainly not the only one, but it's a very important one. And it's where we really want to pay attention to the normalization. So the first thing we're going to do now is to remove the redundant columns. Okay? And there are two kinds of columns that we want to remove. The first one is what I would call a truly redundant column. And the second one are columns that can be calculated. So let's look at each of those. Okay? So we're going to bring up our data model again. All right. And we don't have a truly redundant column, but we'll create one. Okay. Let's see. Oh, actually, we do have a truly redundant column, and that is the following one here. If you look at class meeting, okay, we have an instructor name, okay? But really, do we really need to know this? Because if we know the class meeting and we know it has a relationship with the course offering, okay, so we can find our way to the course offering. And if we know that we have a course offering, we know that we have an instructor name. Okay, so that we don't have to keep this duplicate information, this redundant information down under class meeting. We can simply build the SQL in our query to join those other tables and get the instructor name off of the instructor table and to include it in the result set that we want. So instructor name is duplicate. So let's cut that whole column or attribute, instructor name. Now it's gone. Okay, so we got rid of one redundant column. Okay, that sounds good. What about the course name? Same deal. Okay. If we know that the class meeting is for a particular course, okay, and we know that the course name, okay, is available on the course offering table, well then it's redundant to keep the course name here on the class meeting table. What we would do to get the course name would be to join that other table in our SQL query and get the course name from that. So we don't want course name here. It's redundant. Okay, and we're going to cut that. Now that's gone. Wow, that's much lighter. Okay, so those were two cases of redundant columns that we just eliminated because we didn't understand how relational databases worked, and so we were keeping them associated with the class meaning, even though they're really more appropriately a part of the course offering and or the instructor. Okay, and that because we are able to join tables in our query, we're going to be able to get those into the answer set without having them redundantly kept here in the class meeting table. So what's interesting is the only thing that we have as a piece of non-key data for a class meeting is the class meeting password. Well, that's pretty interesting because all classes are going to be the same in every respect, except I'm going to change the password for each one. So that looks like we've gotten rid of truly redundant columns, and that's the first part. The next part has to do with columns that can be calculated. And before I do that, I have to foul up the model just a little bit. So we'll pause while I do some model destruction so that we can come back and fix it. So here's our pause. Okay, welcome back. I've done the damage, and I've done it right here on class meeting. And typically, this is a problem when you're, say, keeping totals of things. So in this case, the question is, how many students attended that particular class meeting? Okay, so we think, well, we could, how can you come up with that fact? Well, if you really understand this database design, you'll know that there's a relationship between the class meeting and the student. So let's wander up here to student. Okay, where you can tell that the student attended the class meeting. Well, how could you figure that out? Well, you could count the number of instances of the relationship that you had. So for every student that attends a class meeting, there's a relationship between that student and the class meeting. Okay, so if 35 students attend, there should be 35 relationships to count. Well, what if we would like to keep that total down here on the class meeting table? Well, those purists, myself included, would say, well, the problem with that is that then you've got the same fact in the database twice. How many students attended the class meeting is in the database as a series of relationships, okay? And in each of them is a fact, and you can add them up, and then you can come up with the total attendance fact. So then if you store that, then you have a different expression of that fact, which is great until they get out of agreement. So one of the reasons that we don't keep redundant facts in the database is we don't want them to get out of agreement with each other and for us to lose confidence in the data. So here, what we're going to do is we're going to say, in order to have a properly normalized, non-redundant database, we want to keep total attendance. We're not going to keep it on the database. We're going to cut that. Okay. And how are we going to get that information? Well, every time we want to use that information, we are going to join class meeting to student. Okay. And we're going to have another table in between, because the next to last thing is we're going to resolve many-to-many relationships, and we do that, we're going to have to add an extra table, an intersection or associative table between class, meeting, and student. And when we do that, we're going to call that attendance, okay? And we're going to count those, okay? And how can we count them? Well, we can use the count function in SQL. So we'll do a join and we'll do a count and we'll get that fact without explicitly carrying it on the database. The other situation that you get a lot is where you have, let's say, orders and items. And so you have a series of items that are on an order, and then the question is, do you have to add up all the items to find the total amount of the order, or do you carry it on the order itself? And most database designers would say that the safest thing to do is to make the normalization improvement that we don't carry it both on the order and on each of the items, that we record it on each of the items, and then when we want to know what the total amount of the order is, we sum all the items, and we do that with the SQL sum function. So now we've made a couple of changes, and these are all the things that we need to do to remove redundant columns. Okay? So the next thing we're going to do, let's just take a look at our method. So the next thing to do, and I'd like to cover it here, is remove redundant relationships. Okay? And what is kind of interesting is that, of course, the column that we just had, the example that I gave you, the column was redundant with a relationship that we had. The one that I talked about, where we were keeping a column for the amount on each of the items and then a total of all of them on the order, those are truly redundant columns. Okay? But it's possible for relationships to be redundant as well. So I'm going to take a pause here, and again, I'm going to make the model a little bit worse. And when I come back, we're going to have a redundant relationship that we're going to have to get rid of. Okay, so a slight pause while I do my dastardly work. Hi, we're back, and I've done some damage here. What I did is I fooled with my class meeting, and I thought, well, what if I want to know what instructor this is teaching the class meeting? And then I would go, well, that's why don't we just put a relationship directly between the class meeting and the instructor. So I created this relationship taught by, and it's a relationship directly between the class meeting and the instructor. And a lot of novice designers would be kind of interested in this kind of approach. And what they would like is, well, I can get right there. Well, it's a duplicate fact. Okay? And what do we mean by duplicate fact? Well, we mean that in the database, there are two different relationships that you could follow in order to know, sorry, my taught by got lost there. In order to know who the instructor is for a particular class meeting. Now you might say, well, there could be a substitute instructor. Okay, Well, if you know the rules for instructors, you know that we only send substitutes when we're either invited to the White House and or in the hospital. We don't, that's not one of the requirements here. So this is the same kind of error that we had when we had a column that had the instructor name, okay? Because of the fact that we can go from the class meeting and we can join that table to course offering, and we can join those to instructor, if we know the class meeting, we always can know the instructor, okay? Well, so if we create this taught by here, the problem is it's redundant information. It's a duplicate fact. And fine if it's truly duplicate, then it's just a waste of resources. But what if we somehow in the application get it to the point where we record another instructor? Now we have a conflict between facts in the database. So we don't want a design that will entertain potential conflicts between facts in the database, which is why we have to get this redundant relationship out of here. So the one that is the proper one is the one that is a part of this, what I would call holistic data model that shows the proper relationship in the instructor to the course offering and from the course offering to the class meeting. And the one that is evil, or the one we're not going to keep, is the taught by that I just added, because it's a shortcut and it's not good practice because it creates redundancy in the database. So something that I think is hard to get your head around when you're new to relational databases or databases more generally is that facts are recorded in the database by putting values into columns and by adding rows. But facts are also put into database by building instances of the relationships. And those are first-class facts, just like the values in the columns and the existence of a row are. And you don't want any redundancy there either. So because of that, we're going to fix this problem by highlighting that taught by that we just added, and we're going to give it a cut. Okay, so let's review what we did in this particular video. Well, we removed redundant columns, okay? The truly redundant columns we removed. Columns that could be calculated from other columns or other facts in the database we removed, okay? And then we removed redundant relationship. We had that shortcut that we foolishly added as a kind of way to shortcut the relationship between class meetings and instructors. And we decided that even though we originally thought that was an appealing idea, that was redundant information, and that we were just going to have a single way to get that information, and we were going to get rid of that new relationship because it had a redundancy problem. So we're going to pause. We're not going to pause. We're going to say goodbye here, and we're going to move you on to the next of the tutorials, which is on eliminating repeating columns. Bye for now.